Hello everyone. In this lecture, we will continue to learn plumbing system. So let's review plumbing system component like domestic water. Like usually for supply water, we have to consider temperature. We have to consider treatment for potable water and filtered potable water and wastewater. So we need to use a DWV drainage waste and vent system to remove wastewater from the building. And what is gray water? So we can recycle, we can reuse gray water. So gray water includes the water from bathtub, water from washing clothes, and water from air conditioning. And what is black water? Black water usually includes solid and liquid. So like the toilet, water from toilet, water from kitchen sink. And fixtures, drains, carriers, specialty equipment. So we learned in the second lecture of the plumbing system, fixture, material, and fitting, wave, roof drains and piping, rainwater capture. So we will learn the rest of the two in today's class. Let's review some of plumbing fixtures. We have to consider install supply water pipe and drainage system. Like water closet and urinal have a floor-mounted wall hung and automatically flush valve. So usually we have to install supply water to water closet and urinal, and also we have to remove wastewater from there. And the water from the urinal and from water closet, usually we call them as black water. Lavatories and sink. So you can find it in bathroom and kitchen. So standard lavatory use a 2.5 GPM, so we have to consider gallon per minute as their unit. And for the water closet and urinal, we have to use a GPF, gallon per flush. And a high efficiency lavatory as low as 0.5 GPM. For the floor drains and floor sink, we don't need to install drainage system. That means we don't need to consider supply water for them. Usually we use them to remove water in roof and floor to make cleaning. And what is clean out? So we have to supply water to the building, use a main pipe on the ground. So for the remove wastewater from building, we also need to have a main silver line, or we can say this private silver main. So that's when we have to consider install clean out to allow the plumber do regular maintenance. They don't need to access to the building walls. They don't need to dig the soil on the ground. So the clean out can provide the areas, allow them to do maintenance. And how to install clean out, how to design clean out appropriately. Clean out will require air changes in direction greater than 45 and a specified interval no greater than 100 apart. That means less than 100, we need to include one clean out. And beds of sticks we are leaving building, so we cannot install it within building. Most of the time it should be remove the building, the water outside of the building, the wastewater pipe outside of the building. We have to consider install clean out. Location by code. So most of the time, if you are owner, you want to install water closet or urinal in your building, in office building or in residential building. So you cannot directly install that by your imagination, because sometimes this problem happens. Like in the 2D drawing, in the plan, you find, okay, this location, this area, we can place a urinal or water closet, but you may disregard the people usage problem. So how to address it? we have to check plumbing code, like what's the exact clearance between urinal or between water closet, what's the size we have to provide for the urinal design. Like this one, the OC, the center to center, the clearance is 21. Okay, and also like this one, center to center is 30. And we need to consider like from wall to the water closet or urinal is 15. For the different country, different type of the building, they may have the different clearance. Like for the urinal design, maybe the clearance are different, especially for the wheelchair. The people they are using the wheelchair. So again, like you have to check the plumbing code, make sure your design is appropriate. And also for the bathtub, what is size you need to consider between the water closet and the bathtub. They also have a clearance design. And we already reviewed the plumbing fixtures. Let's see the DWV. DWV is a drainage, waste, and vent. So most of the time we know the drainage system, we want to remove wastewater. So here is purpose to safely remove liquid and solid waste from the occupied structure to approved point of discharge. Like we can remove them to the retreatment plant company, and then after the treatment we can deliver them to like a river, ocean, some public water resources area. That's the purpose of the DWV. Let's see what's a big picture in a city. Like here we can suppose to the it can be supposed to the residential building. We want to remove wastewater from residential building, and then on the ground, on the street, the public street. So you can find the other buildings, hospitals, schools. They remove the water to the public sewer means, and then everything will be go through sewage treatment plant and then go to the river. So the supply water, that's a reverse the water delivery process. Like for supply, that's from river, public water resources to the treatment plant, and then go to the different destination. For the drainage, so from the end user to treatment, and then to public water resources. So if you want to consider install the horizontal public sewer main or horizontal drainage branch, what you need to consider, like slope. You'll have to use gravity feed to remove water. Usually we don't need to use pump to provide pressure to let the water deliver. Like usually for the supply water main, we want to supply water to the residential building, and we have to consider the fixture pressure flow, right? And then sometimes we use a pump to supply pressure. We consider the valve to increase pressure. But for remove water, we don't need to use pump. We hope that everything can remove by their gravity feed, like use slope. And what's that? Clean out or connect to the end user building areas. Like water goes through this area, the vertical stack, soil stack, and to the public sewer. And the pipe slope flow by gravity and follows paths of least resistance, this pipe slope. So I will introduce how to find how to use a pipe slope to select appropriate drainage pipe size, or use a pipe size diameter to select pipe slope. And the pipe materials, so similar to the supply water pipe material, cast iron, PVC, stainless steel, copper, and steel. So do you remember the steel can deliver the extremely high temperature gas and steam? So make sure you can review that. Steel, what is water condition, air condition, we can use steel, extremely high temperature gas or steam. Let's see components of the DWV. So again, gray water. So what is gray water? Washing machine, like clothes washer, laundry, bathtub, air conditioning. Okay, we can remove water and then recycle to use. And wastewater, toilet, kitchen sink. Okay, and then we remove them to public sewer means. Let's see the water and supply system combined. The black one, drainage system, you can find this below picture. Okay, we remove the water from the drainage system. And what is a vent? So above the picture, you can find this area, the white one, this vent pipe and vent stick. So they are connected to the outside of the air, usually connect to the roof to make the air pressure balance. Okay, this area connected to drainage system. And let's see some terminology describe the component of the DWV. Rider, stick, they are vertical. Like a rider, vertical water supply. Like the water. Let me show something. So we want to supply water from this area. And then we want to supply up one. We manage a vertical line. And then to horizontal, maybe to the kitchen, okay, to the water closet. So that's one, the vertical one. They are rider. And also we want to remove them. We want to remove the water horizontal and vertical, connect to the silver main. The vertical one, this stick. So that's a little bit confused, so let me draw other one. Like here is a building. So on the ground, the supply water main on the ground to up area, supply water like WC, laboratory, supply water to WC, supply water to laboratory. So they need to pump, increase pressure to supply water go up. So this pipe is a rider, and the horizontal one to supply to water closets, supply to the laboratory, they are horizontal pipe, they are branch horizontal. And also we need to remove water from water closet, from laboratory, and then vertical public silver line, silver means. So horizontal pipe branch, and last one is stick, the vertical DWV. So vertical DWV stick, horizontal branch, and mains like this one supply mains, this one drainage mains. And a horizontal branch, a drain pipe extending laterally from a soil or waste stick, or building drain with or without vertical section or branches which receive the discharge from one or more fixed drains and conducts it to the soil or waste stick. So like the soil stick, and then connect to the silver mains. to remove the waste water from the whole building. And they have the like WC, lavatory, kitchen sink, so the different fixture unit. The horizontal range will connect to the one or more fixture drains. And soil pipe. So you can see this one, soil pipe. So what's that? Pipe convey the discharge of the water closet, urinal. So like this one connect to the different plumbing fixtures. Have the similar functions of collection and removal of domestic sewage with or without discharge from other fixture to the building drain and building sewer. So soil stick connect to like a vertical or connect to the drainage system, the sewer means on the ground. And also like this one, stick vent. So this area this fit connect to the soil tank or and vent tank. This one is open. This connect air in stick vent, liquid or solid in this one, in this area. And the plumbing vent, so we always mention the DWV have the drainage waste and vent. Like for most of us, this is easy to understand. We need to supply water to fixture and we need to remove waste water from fixture. And also why vent is important. We said the vent can put the air pressure, water pressure balance in the building, in the pipe. Like the vent usually connect to top of the roof. That's open. Connect to top of the roof, so they can make the air pressure balance. And that's when the fitting connect to this area. Water solid. Okay, lavatory only liquid in this area. Water will be go through, and here is air. So pipe provided to ventilate the plumbing system to prevent tramp, safety and back pressure, or to equalize the air pressure within the drainage system. This one is a more detail, like vent tank. You see below the fixture unit, drainage, system to sewer. So vertical one, stick, drainage. Horizontal pipe, branch, stick, and also branch. Okay, and how about the connect to the drainage system? This is vent. Okay, and also like this one, vent. So vent system is connected to the drainage system. Combine them, we call this DWV. Here I put the plumbing code for the plumbing vent. We can find for the vent required each plumbing fixture tramp, except as otherwise provided in this code, shall be protected against safety and back pressure. So that's why we need vent. Air circulation shall be ensured throughout all parts of the drainage system by means of the vent pipe installed in accordance with the requirements of this chapter. So, 901, this chapter, they introduce a plumbing vent as otherwise required by this code. So we also need the trap seal protections of vent system. We have to consider trap seal. Prevent a trap seal from being exposed to pressure differential that exceeds 1 inch water column. And this figure, that means like vent. So why? Because you can find the drainage system is closed. This closed. That means we cannot ensure air pressure balance in this system. So we have to make sure it is open to outside. So we have to connect the vent tank to roof. This is open. And also this one, we have to at vent tank. Make sure laundry drainage system have the air pressure balance to outside. And this section, we already learned some terminology for drainage system. We have to consider how to find appropriate pipe size for drainage system. Like for the last lecture, we learned what is WSFU. We use it to find appropriate supply pipe size, supply fixture unit. So for the drainage fixture unit for drainage system. So the unit doesn't mean the plumbing fixture number. That is just a unit number to help us to find the appropriate pipe size. Like sanitary T and Y, so usually we use them in the drainage system, Y sanitary T and double sanitary T. And that one is same as 4-way crosser. Okay. And DFU, let's see how to find appropriate DFU. So for the WSFU, we didn't mention the around number water goes through the 1 DFU, but for the WSFU. But for DFU, we have an easy method to directly find the water goes through there. So 1 DFU around 7.5 gallon per minute GPM. So if you want to, like as the owner, you don't want to spend too much time to calculate exact the water consumption or the peak time water usage, so you can use this method. But for instance, in this class, we will introduce another way, like same as the WSFU calculation method. So check table, and then to read each plumbing fixture DFU to find the total DFU, like a water closet, flush meter width, this one 4, so DFU is 30 by 4, 130. Urinal is 2, 3 by 2, 6. Lavatory is 1, 28. Drinking fountain this one 0.5, so 2. So 1 by 1 to calculate it, and then total DFU, so add all of them, get a total DFU 170. So now we already got total DFU. What we can do? How to find appropriate pipe size? So again, like for the horizontal branch and the silver main, we have to consider use a pipe slope to remove wastewater. So based on designed slope, pipe slope, we can find appropriate diameter of the pipe. Flow by gravity and follow path of least resistance pipe slope, we can find diameter of the pipe, slope per foot, diameter of pipe. And what's the number of drainage fixture unit, DFU. Okay, total DFU is 170. Okay, 170, and slope, pipe slope is 1/8, so this column total 170. We have to choose a larger one, then we choose 4. Okay, this is the pipe size. And then we said we have to remove the wastewater from the plumbing fixtures. We also need to consider remove storm water, like rainwater in roof and on floor on the site, that collect storm water from the roof and move it to a point of disposal away from foundation. Collect storm water from the side and move it to an approved point of disposal. Common feature and difference between sanitary and stormwater system. Like for the plumbing fixture sanitary, we have to consider like we have to make sure have the traps, steel traps. We have to consider vent pipe, and also the point of disposal that different between the sanitary from plumbing fixture and the stormwater, and also like the stormwater absence of volatile gases. And what's the same thing? Like we need to use, we have to consider fitting to change drain direction. Like if we want to remove the rainwater from the roof, like this one, we have to consider fitting, change the drain direction. And the clean out are required. Like for drainage system, stormwater system, clean out can allow the plumber to do regular maintenance. Horizontal drain are graded at a specific slope, typically inch per foot. Like again, we don't want to install pump to remove water, so just use gravity to remove water, especially for the horizontal drain. We need to consider slope. Here are two common roof drain systems. This one, very easy, you can find outside of the building. And for the flat roof drainage system. And for the stormwater, we also need to consider how to find appropriate size to remove the water. What we need to collect, what features we need to collect to find the appropriate size to remove the stormwater. Like the first one, we have to know the rainfall, how much rainfall annually. Like a local annual rainfall, local code for area rainfall maps, rainfall indicator. So the rain system should be considered the large storms. Like we cannot directly use like how much rainfall this year or last year. We have to check the code book to see the average or the largest storm water. And other various area of the roof, rainfall rate, number of the roof drains, slope of the pipe. So let's see an example how to find appropriate size. Example, the building in Kansas. That means we know location, we can find rainfall rate. Okay, check code. Building dimension, like for the flat roof, building roof, we know need 6 roof drains, like a number of the roof drains, horizontal pipes, and 1 vertical leader. This one vertical leader, horizontal branch, all horizontal branch. Slope of the pipe is 1/8. Size pipes and leader, size all horizontal pipes and this leader. And this one, drains, they have the 6. Let's see how to do. First one, we need to find the rainfall rate from the location, Kansas, 3.7. Rainfall rate is an inch per hour, 3.7. And then we can know the leader size. That's on rainfall rate and roof area. What's a roof area? 6 and 60, 90, so 5,400 square feet. Choose the large one, 5 liters diameter. And then let's see the horizontal branch. So I already posed the correct answer. Let's see why we can find this. So we have to evenly separate the roof area. That means for the each drain that will remove water in this area. So total is 5,400, and for the each drain 900 square feet. And rainfall is 3.7. So we choose large one as 4. So this column. First one, the single horizontal branch connect to the drains. They need to remove the water, deliver water just based on the 900 square feet. So 900 square feet, we have to choose the second row, 4. And how about this one? I will change the color. How about this area? Same as this one, only 900 square feet. So 4. Again, this area, 2. The 2 drainage water from the 2 drains will be go through this area. So we have to consider 1800s. 1800s, 4. And this area, 1, 2, 3, 3. Okay. This one, 5. And how about this one? 1, 2, 3, 4, 4. This one, 6, 6. And how about this one? 1, 2, 3, 4, 5. Okay, 5. 6, 6. And how about this one? 1, 2, 3, 4, 5, 6, 6. Okay, same total. Which one? This one. 8. Okay, and the vertical leader, 5. Just make sure the table is different. This table is for the horizontally. This table is for horizontal pipe. This one is a leader, diameter of leader is different, and leader is 5 inch. Horizontal, this area is 8. This is method to find appropriate size for stormwater. And then I also listed some principles of stormwater drainage. So the stormwater drainage system conveys rainwater and other precipitation to storm sewer or other place of disposal. So stormwater discharge point, great, and street, and also like a final point, stream, river, lake, ocean, or other suitable point. So we have to, because they are some water relatively clean, so we can consider 3 of them. But for the drainage from plumbing fixture, we cannot do that. We have to treatment or deliver them to treatment company. And this is the last information into the class. Stormwater strategies, perverse paving. Like I believe this one is very popular now in the parking lot. Perverse. Okay, this one, traditional one. Which one is better? Absolutely. Like you already learned MEP, so you have to know that's very, very popular information. Perverse. We have to use a perverse to avoid too much water above the ground. Like this one, very ugly, and also like after raining, you can find some water in the hole. Okay, so most of the time for the parking lot, for the public area, use the perverse.